So I guess we will move on to the next person. Our next speaker today is Richard Rogers, and he is an entomologist and science communicator from Bayer Crop Science. And the title of his talk is Bees Pay, Calculating Honeybee Stocking Rates for Lowbush, Blueberry, and Almond.
Hello, can you hear me and see my presentation okay?
We can, and we can see your cursor
Great.
too.
Okay, great, thank you. So hello everyone. On behalf of myself and my co-author Stephen House, I'm here today to present a first look at an early updated version of a program we call Bees Pay. This program's used to calculate honeybee stocking rates in lowbush blueberry, and we've recently added an adaptation for almond. So the question that is always on the minds of growers and beekeepers is how many honeybee colonies are needed to pollinate my crop? This is an important question because pollination is an important input for sustainable crop production. Before reviewing the Bees Pay tool, however, I'd like to quickly review some of the important components of crop production that influence pollination and final yield. Firstly, pollinators provide essential pollination services. We've all appreciated that. However, the contribution of pollen transfer, in other words, pollination, in crop production must be appreciated in perspective. There are many other factors that can affect plant health, bloom, pollen transfer, fruit set, fruit growth, and ultimately final yield. The pollen transfer slice of production, as seen in this pie chart, is relatively small compared to the full production cycle. However, pollination is still essential because it provides the spark that starts the crop production engine. Honeybees are the primary commercial pollinator of crops. Therefore, they are an important component of insect pollinated crop production. However, it is important to use honeybee colonies that are healthy and of sufficient strength or size to optimize the number of forager bees. Another important component is plant health, because plant health impacts the abundance of bloom, attractiveness of blossoms, quality of pollen, success of fruit set, and ultimately yield. Finally, pollen is important. Assuming that weather and environment are favorable, crop plants are healthy, and honeybee colonies are healthy and strong, there is a very good chance that pollen will be available and transferred among flowers in large quantities. However, transferred pollen must be quality pollen, which is compatible and has high germination potential. Therefore, to achieve fruit set, pollen must germinate successfully, pollen tubes must grow and reach ovules, and fertilization must take place. Maybe you have noticed, like I have, that humans tend to blame everything on weather. So with crop production, yeah, that's partly true. Weather can impact plant growth and pollination, etc. However, crop yield losses can occur from many other factors and can occur at any time in the production cycle. It's important to identify other factors and assess the contributions of these factors to yield losses. So the purpose of Bees Pay is to calculate the optimal number of honeybee colonies needed to maximize fruit set, but taking into account some of these factors that I've mentioned previously. From this chart, you can see that maximum fruit set is equal to yield potential, which is the maximum theoretical yield. So in other words, yield, you can't get a greater yield than this maximum fruit set. Achieving a final yield that is equal to yield potential is nearly impossible. However, maximizing fruit set is a good starting point toward maximizing yield. So now let's take a look at the bees pay model. Please don't try to read the text and numbers in this graphic. It is simply an overview of the tool. But if you can see the numbers and text, that's fine. The structure of the original version of bees pay is highlighted by the red box. The first section lists all the variables used by the equations. And these variables are in this yellow column here are A to Q, and these are used to calculate stocking rate. The second section is a collection of sub-equations that generate useful results on their own, but are also part of the overall stocking rate calculation. The third and fourth sections are the results, including stocking rate per hectare converted to per acre for convenience, and cost of stocking per hectare and per acre. So we're looking at stocking rate of bees plus the cost of stocking rate. Here we have a red box outlining the new section that was added for calculating honeybee stocking rates for almond. Stephen and I were not sure if the same variables would apply for the almond crop. We discovered, however, that most variables could be used as is, with only a few requiring modified definitions. However, many of the value ranges, which would be the second column from the left, required a few modifications or changes. More research is needed to identify typical ranges, so there's lots of work to do here yet. But I think we've got a good start on identifying what numbers we need to use, and then how we'll have to figure out how to measure them. So in this chart, we'll take a closer look at the variables section for lowbush blueberry and compare with almond. The A variable is the number of viable blossoms per unit area. In the case of lowbush blueberry, the unit is meter square. The unit was changed to hectare for almond, and the value range had to be updated as a result. This change also meant that some of the equations for the almond side had to be revised. Variables B to F are related to pollen compatibility, viability, and availability, as well as requirements for fruit set. Value ranges are mostly similar for the two crops, but more work needs to be done, as mentioned, to confirm these numbers, especially for almond. Variables H to M are related to bees, visitation, and pollen deposition. Again, the value ranges were mostly similar. However, according to some published numbers, almond flowers visited per day are 2 to 4 times that of lowbush blueberry. Therefore, it is important to determine if the numbers are valid and why. I was expecting that much higher numbers for visitations on almond flowers would lead to a very different stocking rate result than for lowbush blueberry. I will show the results shortly, but I was very surprised. The last two variables, P and Q, are related to the cost of renting individual colonies and the value of the crop on a per kilogram basis. This red box outlines the new section added for almond sub-equations. The primary modification was to change the units in the first equation from meter square to hectare. So far, all the other sub-equations seem to work as is, but more rigorous validation is needed. As mentioned earlier, there are many factors that can lead to reductions in actual yield. This table captures percent reductions by the listed factors. And these values can be estimated early in the season to run what-if scenarios. Then as the season progresses, some losses will be directly measurable and can be updated in the table for more real-time results. Here is the summary output generated by the BeeCon calculations. It reports stocking rates per hectare and per acre and allows input of actual stocking rate, so what you actually used. It has a section related to cost of stocking per hectare and per acre. Also, a section that reports fruit estimates, potential yield, actual yield as a manual input, and comparison of actual versus calculated yields. Finally, there is a section that generates financial details and compares revenue from various stocking rates versus actual stocking rates. As you can see in the red outlined area, we are still working on the recently added almond section. However, the stocking rate results for both crops are being calculated in this new version. I was thrilled to see that these results are very similar to typical recommended rates. The fact that these numbers were generated from bottom-up variables suggests that the variables and mathematical relationships used by BeeCon are realistic. Refinements and improvements can be made, but BeeCon seems to hold promise for answering the question, how many honeybee colonies are needed to pollinate my crop? In closing, here are a few take-home messages. For the sake of time, I will only mention the last one. That is, BeeCon and other calculators and models may help to improve the precision of pollination services, as well as improve management of other factors which impact crop yields and revenue. So now I'm happy to address any questions if there's any time left. Oh, acknowledgements. I do want to acknowledge all the work that went into getting the numbers for the lowbush blueberry side of things. This work was done over the years, starting back in the 80s, and Steve Javrick, Corey Sheffield, Kenna McKenzie, and Sam Vanderkloot. So thank you.
Excellent. So we do have time for at least one question, and there is one in the chat. This is from Anna Maria, and they ask, is there an article published with this model?
No, there is not. The plan is to publish something, but we still have some work to do on the almond side before we get to that stage. So thank you for the question and the interest.
There's another question. This is from Richard Odemer, and they ask, what do you think of measurement of colony flight activity to provide a more accurate metric of the foraging efficacy of honeybee colonies in blueberry?
Yes, knowing the number of bees flying and relating that to proportion of bees from a colony, also the direction of flight and what flowers they're visiting, all of that can come into play and be incorporated into the model. Right now, we're just making assumptions that like 30% of the bees in a colony are foraging, and we're estimating loss of bees to other plants outside of the crop. So, you know, there's definitely some refining to do there to make it more accurate. But in the beginning, as long as we can make assumption values work to a reasonable extent, we can certainly refine the numbers. So that, yeah, if there's any contribution he wants to make, I'd be happy to hear how that might do, how we might work with that.
All right, well, I think that is everybody.